Hello, this is Professor Keene, and welcome back to Introduction to Astronomy at Wisconsin Lutheran College, where we've been discussing Ptolemy's Almagest. This is the famous book on astronomy that he wrote in the 2nd century AD. In the last lecture, we talked about Ptolemy's preface and also his chapter 2. In chapter 2, he gave an outline of the kinds of topics he would be discussing in the remainder of his book. Today we're moving on to his chapter 3, where he begins to discuss his arguments that the heavens themselves move as a sphere. This is in chapter 5 of A Student's Guide Through the Great Physics Texts, volume 3, on page 44. So, the title of this chapter is that the heavens move as a sphere. What he's basically telling us is that he's in agreement with the work of Aristotle, that the heavens themselves are in the shape of the sphere. He says that the ancients believed this. It's funny to hear about Ptolemy referring to the ancients. After all, we sometimes think of Ptolemy as an ancient, but he mentions that the ancients believed that the heavens themselves are in the shape of a sphere. Why did they believe that? He said it was on account of their observations. They watched the daily rising and setting of the sun, the moon, and the stars, and he noticed that the trajectories through the sky followed circles that are parallel to one another, and the most natural shape for an object carrying all these parallel circles, he argues, would be a spherical shape. So he is in agreement with Aristotle on this issue, that the stars, the sun, the moon, the planets are all riding on these spheres. That's what he means when he says the heavens move as a sphere. He says this is especially evident while looking at the always visible stars, that is, the ones that are near the North Star. So if you look northward at the North Star in the evening, you'll see that there are a number of stars that never do rise or set. Rather, they travel in circles around Polaris. And this is more evidence, he says, that the heavens move like a sphere. On page 45, he talks about some of the alternative theories that he basically presents as failed models. He says that one of the failed models is that the stars move in straight lines. So this might sound perplexing to you. Why would anybody argue that the stars move in straight lines? Well, you might think about the trajectory of an airplane. So if it's flying from, let's say, the northern horizon straight toward you and over your head and then flying off to the south, it's moving in a straight line, but it looks like it rises out of the horizon, flies overhead, and sets at the other horizon. This apparently is what some people were arguing about the stars. Why do they rise in the east and set in the west? Well, maybe they're flying overhead in a straight line, and so they would appear to rise in the east and set in the west, but really this is just by virtue of the fact that they're moving very far away from us. You might suspect that this is believed by some of those who thought that the earth was a flat plane and the stars are flying over our heads. But Ptolemy argues here that this is a bad model. Why does he say they're a bad model? Well, one of the pieces of evidence that he provides is that if this was the case, then they should appear very small when they're at the horizon. And then as they get overhead, they should appear very large, and then once again very small when they pass to the other horizon. He says since they don't do this, the idea that they move in straight lines is a faulty theory. He also considers another model where apparently some believed that the stars were kindled, so to speak, in the east. You might think about a mountain chain off across the ocean in the east that shoots out these fiery stars each night. They travel overhead, and then they're extinguished, he says, in the west as they perhaps fall into the ocean. Now, of course, Ptolemy rejects this idea, but why does he reject it? He does not reject it out of hand, rather he provides an argument. He says that it wouldn't make sense because it would be too coincidental for these stars that are kindled in the east and extinguished in the west to adopt the exact same configurations night after night after night. After all, the stars follow the same patterns. They form constellations. And he says that these regular patterns cannot be accounted for by chance and by randomness. Rather, there needs to be some other explanation for the orderly behavior of nature. He says also that another argument for the sphericity of the heavens is that there are, when we measure time, he says we use spherical astronomical objects. You might think of like a sundial, or a sundial has perhaps a spherical or at least a curved shape for the gauge on which the shadow of the sundial falls. Or you might think of the spherical astrolabe. Some of you built this in lab in the previous weeks. The spherical astrolabe is used to model the motion of the stars. He thinks it would be too coincidental if these spherical astronomical measurement devices that measure time and motion worked so well if the spheres themselves, or if the sky itself or the heavens itself was not a sphere. He also mentions that the sphere is the greatest. Here's another argument for the sphericity of the heavens. He says the sphere is the greatest three-dimensional object. Okay? And so it is sensible that the celestial body that's rotating around us, which is the greatest object, is a sphere as well. So let me write this down, because he's using a syllogism here in order to explain why he thinks that the heavens are spherical in shape. So here's the argument. Here's premise one, is that the sphere is the greatest object. Okay, and premise two is that the heavenly body, the thing that's carrying the stars, the heavenly body is the greatest body. And then he argues by means of a syllogism, if you assume that these two legs of the syllogism, so to speak, are true, then the conclusion one can draw is that the heavenly body is a sphere. Now, you may or may not like this argument. This is the form of a syllogism. It's a kind of argument. We talked about this a little bit before. But if you're going to reject this reasoning, one can do that by either rejecting the first premise or the second premise, or to say that the reasoning from these premises does not lead to the conclusion. Okay, so how would one take issue with these premises? And I think one thing that we have to keep in mind is that he's using the term greatest in perhaps a different sense in these two legs of the syllogism. So if you're going to attack these, you might say he means something different by greatest in the first premise and in the second premise. So what I want to do is I want to do a short aside on terminology. Here's a short aside on terminology. And I'm going to write down some words and I'll explain what I'm talking about. And you'll see where I'm going with this in a few minutes. So when you speak and you use terms, you can use terms in what is called a univocal sense. I'll just write these down first and I'll explain it. A univocal sense. You can also use terms in an equivocal sense. Equivocal. Or you can use terms in an analogical sense. What do I mean by this? Well, let me do this by means of examples, and then you'll see why I'm drawing these distinctions. These, by the way, are distinctions that Aristotle draws in some of his works on logic. Okay, so let's suppose you make a sentence. You state something like, the dog has legs. Okay, and then you make another sentence, you claim that the cat has legs. Now, you're using the word legs in both of these sentences, and you're using them in the same sense. When you say the dog has legs and when you say the cat has legs, you mean the same thing by the term legs in both of those sentences. You're using the word legs in a univocal sense. Una meaning one, vocal is speaking or calling out. Okay, so you're calling out or using these terms in the same sense. What about the equivocal sense? Well, let's suppose you say the bat flew up the chimney. And let's also say that I swung the bat at the baseball. When I'm using the term bat in the first sentence and when I'm using the term bat in the second sentence, I mean something completely different by the term bat. So there is an equivocal sense here. That is that I'm using the same word, an equivalent word, but I mean something completely different by bat in the first sentence and in the second sentence. Okay? That is the equivocal sense of those two words. Now, what about the analogical sense? What if I say, go back to my first example, the dog has legs? Okay? And then consider this phrase, that idea has legs. So I use the word legs in both sentences, but I don't mean the exact same thing by them, but I don't mean something completely different by them either. After all, when I say the dog has legs, I mean it has some ability to get up and move around. And when I say that idea has legs, I mean that idea, that might take us someplace. That's a good idea. It can take us from one place to another, right? So there's a sense in which I mean the same thing, or at least a similar thing in these two sentences. There's a deeper meaning that I ascribe to the word legs in both of those sentences that is similar. This is what we mean by an analogical sense. So I'm using the term legs in both sentences in an analogical way. There's a similarity, but they're not the same. Okay? Now, why am I doing this digression on terminology? Well, in this argument here for the sphericity of the heavens, one could argue that Ptolemy, and Aristotle for that matter, is using the word greatest in an equivocal sense. After all, the sphere is the greatest object. Perhaps they mean something like it is the most important object. And they say the heavenly body is the greatest body. Perhaps they mean the largest body. So they mean something very different by greatest in those two sentences. So if that's the case, then they're equivocating. They're saying they're trying to use a similar word, but it means something very different. So the conclusion that the heavenly body must be a sphere doesn't follow from these two premises. Now that's to take a very critical approach to this reasoning. I suspect that Ptolemy and Aristotle might argue that they're using these terms in an analogical sense, that they mean something very similar by these words, although not exactly the same thing. So that would be to put a positive construction on this argument. You can decide how much value you put in an argument like this. People like Aristotle and Ptolemy use these kinds of arguments quite commonly. Okay? So, all right, so that's this discussion from chapter 3 on his arguments that the heavenly body moves as a sphere. Tell you what, why don't we take a break there, and next time we will talk about chapter 4, that the earth too is generally spherical to perception. That is, that the earth itself, as far as our senses tell us, is spherical in shape.